All right, let's look at some properties of definite integrals. All right, so if you think in terms of area, these are actually pretty natural. All right, so if you have an integral from a to a, so it starts at a and ends at a of f of x dx. Right? In terms of area, you're talking about the area of the region whose width is 0. So the area is going to be 0. So if you have the lower limit equaling the upper limit, then the integral is always 0. All right. If you switch the lower limit and the upper limit, it's going to only change sign. So it's going to be a negative of the integral from a to b and f of x dx. Right? And the third property is if you have a constant multiple, then you can always kick the constant out. So if you have a constant here, we can kick it out in front of the outside the integral. So you have a k times integral from a to b f of x dx. Right? And the next one, if you have addition or subtraction, we can do the integral on each first. So you have an integral of f of x, and you do the integral, find the integral of g of x separately. Then you can carry out the addition and subtraction later. All right, number 5. If you have an integral from a to b, you can actually split it into from a to some other number c, f of x. Kind of taking a break there at c, and start back up from c all the way to b, and we have that. All right. And property 6, if a function is always bounded below by lowercase m and bounded above by uppercase m, then we can bound the integral from a to b of f of x. Right? This is going to be bounded by lowercase m times the length of the interval, which is a b minus a, and bounded above by capital M times the length of the interval. Again, it's b minus a. Right? So those are the simple properties of definite integrals, and they are very, very intuitive. So I don't think a lot of people have trouble remembering those. All right, so let's look at a couple of examples here. We want to write as a single integral form. All right, so we have this integral from negative 3 to 2, and integral from 2 to 5, and then you have to subtract from integral from negative 3 to negative 1. All right, so first thing I would do is we can combine these two guys together, right? Because integral is going from negative 3 to 2 and start back up 2 to 5. So we can consolidate it as an integral from negative 3 to 5, because you're going to go all the way to 5, of f of x dx. Right? So that's that. And here I'm going to use incorporate this negative sign to switch upper limit and the lower limit. So we can turn it into addition, the integral from negative 1 to negative 3. Right? F of x dx. Right? Then we can combine this since it's going from negative 1 to negative 3 and negative 3 to 5. So therefore, this is going to be integral negative 1 all the way through 5, so negative 1 to 5, f of x dx. Right? So we could successfully rewrite the expression as a single definite integral. Right? So that was the first example. And next example, we want to find the upper bound and the lower bound for the following definite integral. Alright, so let's look at this function here. So this is the integrand, so I'm going to call this guy f of x. Right? Then we want to see if there's a bound for this. Right? So f of x All right, what would be the largest value we can get out of this? All right, looks like the x goes from negative 4 to positive 4. The biggest value you would either plug in 4 or negative 4. So this is square root of 4 plus 4 squared. So 4 squared would be 12. I mean 16. 16 plus 4 is 20. Which is square. Well, let's see. So 20 is what? The 20 is let's see. 2 and 10. This is another 2, 5. So this is 2 square root of 5. All right. And the lowest number we can get is probably when you plug in 0. So square root of 4. So it's actually square root of 4 is 2. All right. So f is between 2. So you can think of this as lowercase m. And 2 times square root of 5. So this is going to be uppercase m. All right. So what we can do is, let's see, we have m times the length of the interval. Length of the interval is 8. So you can see that the 2 times 8 is going to be 16. Right? And the 2 square root of 5 times 8 would be 16 square root of 5. Right? So those are the upper limit and the lower limit of this definite integral. All right? That's it. I hope that this was clear.